All right, so what we're going to be focused on today is polynomial division. Do you guys remember in Algebra 2 doing long division with polynomials? And then synthetic division? That's what we're going to be reviewing today. Those are our big ideas. So I want to use long division on the first two problems, and then we can kind of remind ourselves about synthetic division. All right, so P of x, this is our divisor, goes on the outside. F of x is our dividend inside. So I have 9x plus 4. That goes underneath or inside my division symbol there. I'm going to put the divisor, 2x minus 5 on the outside. You're going to figure out how many times 2x minus 5 goes into 9x plus 4. So we're usually just looking at these first pieces here. You want to figure out how many times does 2x go into 9x. How many whole times can 2x go into 9x? 4. So we're going to put 4 up here, and then we're going to distribute that. So I would have 8x and a negative 20. Anybody happen to remember what we do at this point?
We have to subtract the whole thing.
Subtract the whole thing. So what does that mean happens to both of my signs? They're both going to switch. We're going to subtract this whole thing. So I have 9x minus 8x, which leaves me with 1x. 4x minus a negative 20. Plus 24. Up on top, this is my quotient. This is q of x. So q of x is 4. And down on the bottom, this is my remainder. So that's r of x. So r of x is x plus 24. Can anybody think of how I could check this using the division algorithm to make sure that I did this division correctly? Yes. Yep. If I take p of x and I multiply it by q of x, so p of x was 2x minus 5. I multiply that by q of x, and then we add our remainder. I should end up with my original function f of x. Does that work? Yep, I would get 8x minus 20 plus x plus 24. When I combine my like terms together, 9x plus 4. And so now I know I did it correctly. Any questions so far? Yes, sir.
Do we have to check?
Do you have to check? No. However, it's a good idea to check, especially if it's like on a test and you have time, or on a quiz and you have time. Obviously, it's more important to get through all the problems first, but once you've gotten through all the problems, if you have extra time, go back and check things, because it would, if you do show the check, but you get it wrong, maybe you don't have time to fix it or find it, but if I see that you've done a check, I can give you points for just simply knowing that you've made a mistake. Does that make sense? There's a lot of value in knowing when you've done something right versus knowing when you've made a mistake. And I understand on a test you might not always have the time to find your mistake, but being able to identify that you've made a mistake shows a deeper understanding than just doing it and moving on. All right.
Don't finish the problem just right. I know I got this wrong. You get extra points.
If you show a check
Oh.
and it doesn't come out, then yes.
Like,
Yes.
how many points?
It depends on how many points the question's worth.
Like,
I mean, if it's a 2-point question versus a 10-point question, I can't necessarily say. And it would depend on where the error is. All right, let's try this one. What is going to go on the outside? X squared minus 3 goes on the outside. This is my divisor. So x squared minus 3. My dividend is what goes underneath. 2x to the 4th minus x cubed minus 3x squared plus 7x minus 12. First thing I need to ask myself is what? Not going to help me on this problem. Black.
How many times does x squared go into 2x to the 4th?
How many times does x squared go into 2x to the 4th? Or if I divide these two, 2x to the 4th divided by x squared, what would I have? That's another way of figuring this out. 2x squared. So this is what I'm going to put up on top. Normally, we like to keep our powers lined up. I'm not going to take off points if you don't put them in the right spots. But I would put it right here because that keeps it in the x squared column. I think of this like place values like hundredths and tenths and ones. We're going to take that guy and distribute him. So I would have 2x to the 4th minus, should I put this next piece underneath the negative x cubed?
No.
No, why not?
It's not a cube.
It's not a cubed, it's going to be a squared. So I have negative 6x squared. And then what are we doing with both of those? Subtracting them. 2x to the 4th minus 2x to the 4th, that's going to cancel out for us. What do I do with that minus x cubed? Yep, just take it down. So negative x cubed. I'm going to combine these two together, but remember I'm subtracting the negative 6x squared. 3x squared, positive 3x squared. Bring down the 7x and the minus 12. And then we start the process all over again. How many times does x squared go into negative x cubed? Yep, negative 1x. So this is what I'm going to put up on top. Remember, you can always take those and just divide them. See what result you get. That's what goes up on top. Because when I distribute, I want to get that first piece so that I can make it cancel. So I'm going to have minus x. Then I'm going to take that minus x and distribute it. Negative x times x squared, I get negative x cubed. Negative x times negative 3, negative times negative. So I get a positive 3x We're going to subtract that whole thing. So I have negative x cubed minus negative x cubed. That cancels. Bring down 3x squared. Is this going to be 10x?
No, it's gonna be
4x, because we're subtracting it. And then I bring down this minus 12. What next?
Do it again.
Do it again. How many times does x squared go into 3x squared?
3.
3 times. So I've got plus 3 up on top. We're going to take that and distribute it. So I have 3x squared minus 9. Subtract that whole thing. 3x squared minus 3x squared cancels out. Bring down my 4x. 4x minus what? Minus 3. Can x squared go into 4x?
Nope.
Then I am done. X squared can't go into 4x. So this is my remainder. That's r of x. What's up on top is q of x, my quotient. So q of x, 2x squared minus x plus 3. And r of x is 4x minus 3. How are you guys feeling about this? Pretty good? I'm not going to take the time to check this one, but you could check this one. Sounds fine to me. However, on the homework, if you miss one, maybe go in and check it. All right. You guys okay if I move on to the next? Okay. Awesome. The remainder theorem. If f is a polynomial function, if we take f of x and divide it by x minus c, then the remainder is f of c. I'm going to use synthetic division on this one so that we have a reminder on synthetic division. We did 2 problems with long division. We're going to practice this one with synthetic division. Does anybody remember how to set up synthetic division?
You do like sections, and you have like each term in one section.
Don't you put like all the coefficients lined up and you do like
Yes, we're going to line up all the coefficients. Yes.
There's some weird subtraction.
The other thing is I don't want to use the factor. If I'm using synthetic division, I want the root. So, yes, so 3. Because x minus 3 equals 0, x equals 3. This is what I'm going to use for the synthetic division. I'm not going to get real picky about how you guys set it up. I'll show you how I set it up and why. If you know a different way from last year and you end up with the same answers as me each time, I'm totally fine with that. So I put my root on the outside. And then I do a big bar like this. If you're used to putting the 3 off to the side with a little thing around it, that's totally fine. We want our coefficients on the x's up here in this space. And you have to use every power of x. starting from the highest power. What's the highest power of x that we have here?
3.
Yep, x to the third. So what's the coefficient there? 1. After x to the third, I would need,
Second?
yep, x to the second power, x squared. What is the coefficient on x squared? -4. So I've got to the third power, to the second power. X to the first power comes next. 0, because it's not there. But we have to put the 0 there or else the synthetic division does not work. And then we put our constant. What's our constant? -5. I always mark that last guy out, the constant, because what I end up with right here, that will be my remainder.
Where did you get those numbers from?
These are the coefficients from f of x. So x cubed has a 1 in front of it,
Oh, okay.
and then we have x squared. There is no x, so it's 0 x's, and then we have the -5.
Okay, thank you.
You're welcome. All right, when we do synthetic division, first one comes straight down. You always pull that first coefficient straight down. Multiply your root to whatever's on the bottom, and we put the answer right here. So 3 times 1, I get 3, and then we add. -4 plus 3? -1. And then I take my root, and I multiply it to that newest number on the bottom. 3 times -1? -3. And then I add. 0 plus -3? -3. Multiplication one more time. -9. And add them together. What do I get when I add those together? -14. This is the number that we are after. F of 3, that was my root, is equal to -14. We can check this one as well. If I take 3 and I put it back into my original function in the place of x, so if I evaluate f of 3, I would have 3 cubed minus 4 times 3 squared minus 5. What's 3 to the third power? 27. Minus 4 times 3 squared, so that's minus 4 times 9. So minus 36 minus 5. 27 minus 36. -9 minus 5. -14. Yes.
So like say we got like something like that, and instead of doing this synthetic division, we just plug in like 3 and
Can you just evaluate it at that? So if the problem says to use the remainder theorem to evaluate, then you got to do the synthetic division and you're looking for the remainder there. You can check it by substituting it in, or you can do that from the beginning so you know what your remainder should be. But if it says to do it using the remainder theorem, the work that I would want to see is either long or synthetic division and show me your remainder there. Good question. All right, let's do part B. What's my root? -2. So I've got -2 on the outside. We're dividing the same polynomial, so I'm going to have the same coefficients. 1, -4, 0, -5. I always like to get this guy cut off from the rest. Walk me through the process. Bring the 1 down. Multiply. Negative 2 times 1. Negative 2 and add. Negative 6. Multiply, I get 12. We're going to add 12. Negative 24. Negative 29. So using the remainder theorem, I know that f of negative 2 equals negative 29. Pay careful attention to the directions. Again, if the directions say to use the remainder theorem, I want to see either long or synthetic division to do that. You guys okay with that so far? All right. Let's do a couple more like that. You guys okay if I change the screen?
Yep.
Okay. Same exact thing. I want to use the remainder theorem. I want you guys to do A and B on this one. Give me a real quick thumbs up if you're done with the first one. What'd you guys get the remainder on the first one to be? 130 is correct. Drop that 1 down, multiply, add them together. And then you get negative, what is that, 42? Get negative 46. A positive 138. So we end up with 130 right here. What about the second one? 0. This one is equal to 0. Does anybody know what that means about x plus 1? It's a factor. Absolutely correct. X plus 1 is a factor. Let me get this written down here. This means x plus 1 is a factor of f of x. And that gets us to another theorem, which is the factor theorem. Factor theorem literally says what we just showed right here. If f is a polynomial function and we divide x minus c, we divide f of x by x minus c. If f of c comes out to be 0, then x minus c is a factor. We've got just a tiny bit more to cover in 4.2. We're not going to be able to do all of it today because of the time, but we're going to be able to do some of it today. I want to keep using synthetic division. We've only been writing down the remainders on these. For the next 3 examples, I want to write down both Q of X, our quotient, and R of X, our remainder. Okay? You guys okay if I put that next one up? Okay. So we've got 3 different problems here. We're going to use synthetic division on all of these.
So we can just use synthetic division for everything except for long division?
Pretty much. Pretty much. We'll look at some special cases, like part C is going to be a special case here.
You can only use like synthetic?
For these 3, you can only use synthetic.
You can't use long division?
Long division would work, but for these, I'm asking you to use synthetic division.
So how
Yep.
do we know if we want to use synthetic on the test?
If it says specifically to use synthetic, then that's what I would want you to do. If it doesn't say which one, you can do either or.
Okay.
I want you guys to do A and B on your own. Make sure to fill in any missing powers of X with 0 for those coefficients. Make sure if there's any missing powers of X as you count down that you're filling them in with zeros. What is R of X on part A? 7. We haven't done this yet with synthetic division. I want to write down my quotient, Q of x, but all I have is numbers. Yes. We're going to drop a degree because what we're dividing by is degree 1, right? X minus 2, this is a degree 1 polynomial. So we're going to drop 1 degree, so it's going to be 2x squared instead of to the third, plus 1x plus 6. It's going to go in decreasing order. This is why it's so important to fill in any missing powers of x with zeros, because when you divide it, you might end up with coefficients there. You often do, almost always. If you haven't done it already, please go ahead and do part B. Part C I want to talk to you about before we do it. Yes, ma'am.
How do you get it from 2x squared plus x plus 6?
So here we had 2x to the third. This was x squared, x, and this was my constant. When we divided it by a degree 1, so we took the powers down by 1. So this is going to be my x squareds instead of my x cubes now. And then x to the first power, this is my constant, and this is the remainder. Does that help?
So from the first coefficient, you go down, you just keep going down.
Yep.
So if it was like x 2x to the fifth, it would be 2x to, it would be x to the fourth, x to the third, like that?
Yes. Yes. As long as you are dividing by something that's degree 1.
Okay.
If you were dividing by something that was degree 2,
You go down.
then you would go down 2 degrees. Yep. B is a little bit beastly. If you're getting big numbers here, that does not mean you're doing it wrong. These numbers get very, very big on part B. What do I have in the next column over? I haven't filled in the next piece yet. 4 times 48?
198.
Yeah, I get 192, but then after I add, I get 198, yes. Then I do 4 times 198.
792.
792. Then I have to do 4 times 792.
3168.
3168. And then we add those two together. What is our remainder?
3183.
3183. So let's write down our R of x and our Q of x. What is R of x? 3183. That's the easy part. Q of x.
3x to the fourth.
Yes. So we drop a degree because we divided by degree 1. So 3x to the 4th plus 12x cubed plus 48x squared plus 198x plus 792. Beautiful. All right. Got one more that I want to look at with you today, and then tomorrow we'll finish up 4-2. When I go to set up my synthetic division, what is my root? 1/2. And then what coefficients do I need? 4, 0.
-5.
So 4, 3, 2, so -5, 0, and 1. We're going to drop the 4. We're going to multiply. Yes. Oh, absolutely. I'm sorry. Let me get out of the way. What's half of 4? 2. Now we're going to add those together. So I have a 2 here. Half of 2? 1. Add those together. -4. And so then I have -2. Add those together. I get what here? -1. Add those together, and my remainder is 0. So pretty straightforward as far as r of x.
Uh-oh.
Does anybody see a problem with q of x?
Oh, we don't have a x cubed, but there's one there.
There is. So remember when we talked about how we can check these? I can take my linear factor, x minus 1/2, and I should multiply that by my q of x, which right now q of x looks like it's what? 4x cubed plus 2x squared minus 4x minus 2. What happens if I start distributing this?
We don't get the same thing, but
You get, pretty much you don't get the thing that you're supposed to get.
Do I or don't I?
You get the same.
Let's look. Is this correct? Would that give me 4x to the 4th? Yes.
Oh, yeah.
So I get 4x to the 4th, 2x cubed, -4x squared, -2x, and then what? Minus 2x cubed. Plus x squared, or sorry, minus x squared. Plus 2x plus 1. Does that give me my original function back? Yes, 2x cubed minus 2x cubed minus 5x squared, -2x, positive 2x. So this is my function q of x.
Yeah.
What is special about? I will have to go into that tomorrow. Sorry, guys. I will talk about it tomorrow. Bell cut me off.